Hey guys, welcome to our channel. Please subscribe if you haven't. And today's question is maximal square. Right, this is another Leetcode challenge question. It's the medium question. So given a 2D binary matrix filled with zeros and ones, we need to find the largest square containing only one and return its area. In the example, this is the largest square. We are not concerned with the rectangle, but we need the square. In this, the square would be a submatrix of the given matrix. Now, I can't stress this enough. Whenever you need to find a sub-array of a given array, given integer array, or a sub-matrix of a given integer matrix defined by any criteria, please, first of all, try to think of the approach of the prefix sum calculations. Making a prefix sum auxiliary array or a prefix sum matrix. By prefix sum, I mean getting all the sums for any index I from the starting for an array. And similarly for the matrix, it would be the sum for all the elements up till I and j from 0, 0, right? So this technique is like storing the already computed element in an auxiliary data structure. We call this dynamic programming. Now we will do similar approach, but we'll just tweak our criteria, and instead of doing a prefix sum, we will tweak our criteria that what are I and j in the auxiliary DP storage will represent. Now here in this question, what we need is the maximum area of the largest square. If we can calculate for any given I and j, if we store the maximum side of the square ending at I, j, all filled with ones, right? So in my auxiliary data structure, if I compute for any given I and j, suppose this is the square ending at I and j, all filled with 1. If I store the max of the side of such square, right? If I store these, and then while constructing the DP, I also maintain a answer variable and I do max over it, then I'll get my final answer, right? So this is our state we want to construct, right? How we will construct it? Let's see. Yeah, let's say we want to calculate value for this cell I, j, right? Then by now we would already have calculated the DP value of I, j minus 1 and I minus 1, j, and also I minus 1, j minus 1. Now let's say their values were this here and here, right? Let's label it A, B, C, D. Now what I'll do is I define X here and I define Y here, right? Now X side for my I, j would be minimum of A, B, and Y side for my I, j would be minimum of C, D, right? And for I, j, our minimum max side for the square on I, j would be minimum of X, Y, this side and this side, minimum of this side, right? Plus 1 because we also need to include the cell I, j. So let us code this algorithm and see if it works. Length into a variable and it's same as 0, return 0, m equals to none of matrix 0. And I'll define my DP array. So I'll initialize the by n rows, m columns. This is my max side. This is my answer. So if I'm returning the area of a square, then I would have to do max side into max side. Right? So for I, and now this is where we'll build the DP array. Right? Now I need to define my X, I need to define my Y. So minimum of DP of I and j minus 1 and DP of I minus 1, j minus 1. Right? And this is our minimum I minus 1 and j, and again restricting it to dp of I minus 1, j minus 1. So these are my two sides which have ones, right? Now my dp of I and j, we need to take minimum of this because we need the square, minimum of x comma y, and we need to add 1 to it because if matrix of I comma j is 1. So we only need to do this if matrix of I comma j is same as a1. We also need to keep track of our max side here I comma j. Now I showed you this trick before also. Whenever you have whenever you are constructing DPA for matrix, it's hard to initialize the 0th row and 0th column for these sort of DPs because you get into negative indexes. So what you'll do is you add one more column to a DP matrix. So you add for m plus 1 columns and n plus 1 and make this DP on indexed on 1. So everything that is for I comma j, you'll put that on I plus 1 comma j plus 1 in the DP matrix. And you construct this from 1 to n plus 1 and 1 to m plus 1. So it's just shifted from 0 comma 0 position to 1 comma 1 position. So since it is shifted, we need to check for I minus 1 and j minus 1 in a matrix array. But the DP indexes doesn't change at all. And we just need to change any lookup in the original matrix and do minus 1 on that original lookups. Okay, let's run this code and see if we have any syntax errors. Okay, accepted. Okay, let's submit this. Okay, cool. I think there's a cool trick whenever you want to construct DPs, initializing for one more column and one more row instead of checking if I is greater than 0, if j is greater than 0 conditions. Also make sure you have pretty good handle on recognizing the pattern where you want to construct the DP by doing the prefix sums or constructing the DP by the submatrix from 0 comma 0 to I comma j. These are like fairly common questions in interviews. Thanks again for watching, guys. I hope you like this video. Please subscribe to our channel for more videos like this. Let me know in comment if you want any particular video on Leetcode you are struggling with. We'll try to solve that. Thanks again for watching. Take care. Bye.